Welcome to video clip 6.4, in which we investigate decision logic. In the previous video lectures, we took a look at the decision logic, and now we want to discuss decision logic in a bit more structured way. First of all, decision logic describes how decision output is derived from its input. It can be expressed through so-called value expressions, which might be formal, and as we will see shortly, which do not need to be formal. We can define decision logic in DMN in different ways. First of all, as a literal expression, so through text or through letters, I should say. First way of a literal expression is a textual representation. We can specify the decision logic by normal, plain English text. But we can also have more formal ways of specifying the decision logic, which means through program code in your favorite programming language. But also DMN comes with an expression language called FEEL, which stands for Friendly Enough Expression Language. Decision logic can also be specified using decision tables, as we've seen already. And decision tables are actually also serialized by FEEL. So FEEL is the textual language to represent decision tables in your machine, and also to do input and output when you work with certain tools. Finally, we can specify decision logic through invocation. And we've seen in the last video lecture that decision can call a business knowledge by passing input values and then receiving output values from the business knowledge. So let's look at these different ways of specifying decision logic in a bit more detail. First, look at the textual expression. So the decision logic is provided informally by text. This actually leaves a lot of room for interpretation by the human decision maker. Still, the decision requirements diagram provides an overview of the decision structure. So here we see the decision requirements diagram on the right-hand side, where we decide on application. We need the applicant data, the credit rating, and also supporting documents. And the example here is actually the scenario of renting a flat. If you live in a large urban area, there are often several applicants for renting a given flat. So you need to apply for renting this flat. And the landlord might have the decision logic expressed as a textual expression like this. The applicant lives in a stable partnership and has also a good credit rating. He does not plan to have any pets. All supporting documents are authentic. And by the way, he must be a nice person. So it's clear that this text is just an informal way of specifying the decision logic, which cannot be executed and interpreted by a machine, but only by the human decision maker. But still, the decision requirements shows us what is the input data that we need for taking the decision, and the textual expression tells us what we take into account, how the human decision maker should take the decision. We can also specify decision logic in a literal expression in a more formal manner. And then the decision is executable, and we can express this in the FEEL language. We have an example here, which is the calculation of your net income based on the gross income and your legal status. I have to say that, of course, the example is made up here. Tax calculations are much more complex than we can show here on this one slide, obviously. Okay, so first let's look at the sub-decisions, social contributions. What are the social contributions? Well, social contributions we see in the decision requirements diagram is a decision that takes two inputs, that is the gross income and the legal status. And we see here a FEEL expression that tells us if the legal status equals married, then return gross income times 3.5. Else, return gross income times 4.2. So when you are married, you pay 35%. When you are unmarried, or when you're not married, you pay 42% social contribution. That's encoded here in this decision. And so we see here that the decision is not only possible to have a textual representation or a decision table, but you can also have an expression here, for instance, expressed in the feel language. And then it's easy to determine the net income in this example, and that's basically you take the gross income and you subtract the social contribution, and then this is the return value of the determined net income decision. But of course, the main and most often way of expressing decision logic are decision tables, which is a tabular, formal tabular specification of input-output expressions, which is organized as rules. And these rules specify how output is derived from the input. Decision tables have a number of elements. First of all, there's the name of the table. The table might have a number or has a number of inputs. When the input is unimportant, we use the hyphen symbol. We have it here. That means any symbol matches here. Inputs also have domains. Domains include open and closed intervals. So an open interval 1, 10 here means that it's all numbers that are, say, greater than 1 and smaller than 10. So when it's integers, it's the interval between 2 and 9, including 2. So all numbers from 2 to 9. So that's what we call an open interval. Open intervals can also be expressed as by these types of brackets. And often used are also closed intervals, so from 1 to 10, that's just the interval of the numbers from 1 to 10. We also have simple data types, and we also have enumerations here. So we will find the complete set here of data types, of course, in the standard as well. There are also a set of outputs. Typically, it's exactly one column, but as I mentioned before, it can also be more than one column. And then there is a set of rules, and the rules are actually the rows of the table. In addition, there comes the hit policy of the table, and we'll discuss hit policies in a follow-up video clip. Decision tables can be represented either in the feel language, which is some kind of internal serialization format, but it can also be represented in a graphical way as decision table, and these graphical representation of feel are called boxed expressions in DMN because it looks like a box, and the information is inside of this box. This slide provides an overview of the decision table terminology. So the concrete values here are not so important. I just used one of the tables that we are using in this course anyway. Here we have the rule numbers. So this table has rules 1 through 5, and in the first column there are the rule numbers. Here we have two input sets, which is applicant age and applicant employment status. The concrete values here are the input entries. So here we have input entries. They use intervals, and they also use here element symbols and operators to be used during the matching phase. We also have an output column that is called basic credit card eligibility here. We'll have domains of input values, and we also have output entries. There's something called the hit policy, which we also discuss in detail a bit later. There's a completeness indicator, and this is one of the few things that change in the standard version 1.1. So this completeness indicator will not be provided. And finally, we have an ordered list of output values, and so the output values are an ordered list, and the use of this list also we discuss a bit later. Okay, so the structure of decision table is one rule per role. So if you want, we have conjunctive expressions on input data. So conjunctive means always and, logical and. And we have disjunctions on multiple rows. And what I also like to mention is that the output column is shaded. I don't know how well you see it in the PDF. You see it a bit better. So here we have one output column, and I think all examples that we use throughout this course have just one output column. Okay, what do we mean by conjunctive expressions? So look at maybe this middle rule number 3. Here we say if the applicant age is in the interval between 31 and 65, and the employment status equals employed, then basic credit card eligibility is yes. Yeah? So we say if that holds and that holds, then the output is yes. If, let's look at maybe the last, if the applicant age exceeds 65 and true, so any value is fine here. So if it's larger than 65, then the output is no. Of course, these examples are all made up. Not only the text example is made up, but also from the logic, these examples are completely made up. Just serve illustration purposes here. Finally, we'll have the invocation. And the invocation is done from a decision to a business knowledge. And what happens is that input values of decision table are transferred as parameters to the business knowledge, and the return values are received from the business knowledge to the decision. Here we see it in a bit more detail. So here we have an example, and we also discussed that a bit earlier, where we have the eligibility rules, and the eligibility rules are a business knowledge that is defined by a decision table. So decision logic is defined by a decision table. And we have here the invocation is assigned here. And how the invocation is take place is specified by the decision. So the determined basic credit card eligibility decision has as internal information, the information that you see on the lower right-hand side here. And what does it tell us? Well, it tells us that in order to come up with determination of basic credit card eligibility, I need to invoke the business knowledge eligibility rules. Okay, that's point 1. Point 2 is I need to provide a mapping from the input of the decision, so from applicant age and applicant employment status, to the inputs of the business knowledge. And this is done here as follows. So the applicant age, so the APPH it's called, input of the eligibility rules here is mapped to the applicant age. So we use applicant age. The information stored in the applicant age we transfer it to the business knowledge eligibility rules as input app age. And we use applicant employment status for AMP status. So the AMP status then will go here to the employment status. And this is how the link between these two elements is provided. This is how we make sure that the inputs of the decision are transferred to the right input of the eligibility rules. This brings us to the end of video clip 6.4, in which we discussed decision logic. We discussed 4 ways of looking at or define decision logic. First of all, informally by text. We can also use literal expressions, formal literal expressions, I should say. We can also use decision table. And finally, we can invoke a business knowledge to come up with decision logic. And we've seen here the different examples. So here, the literal expression using English text, the literal expression using the field, formal language. Here we have the decision table. And finally here we talked about the invocation from a decision to a business knowledge. And this concludes video clip 6.4.